Hello everyone, welcome to Rubber Industry NewsHour. We are on the episode number 7. This is a weekly news program for the rubber industry. As you know, now the time is in Singapore 9:30, in India 7 p.m. and Eastern time 8:30, in US and Europe is 2:30 p.m. in afternoon, Central Europe. So I welcome you all for this Rubber Industry NewsHour, episode number 7. I'll give you a quick overview about what is the content in the rubber industry news hour. We have headlines on the news, research, education, tips and tricks, regulations, market review. We'll have also panel discussions. We have business talk. We have a tech talk. We have other talk and also opportunities. We have the business profiles and buyer guide. But not everything in one episode. We will have a couple of things in one episode, but we're covering these aspects in various episodes of the rubber industry, the news hour, because it's aimed for every person, every segment of the rubber industry, whether you're top management, engineer level. So I welcome you all for this rubber industry news hour. I'd like to thank our partners, Rubber World magazine. You can check our website, rubberworld.com. I encourage all of you to be subscribing this magazine. It's free to subscribe for the digital edition. And also we have a Rubber and Tire Digest magazine. That's also free to subscribe for the digital edition, rubbertiredigest.com. And of course, Technobi channel, our YouTube channel, and our network, and the Rubber Industry Network, and also the Rubber Technologies Network. So as they're all actively involved in promoting our rubber industry news hour. Well, as you know, this event is managed and owned by Technobase. I think some of you know already what is Technobase, and you can always check our website technobase.org. For the benefit of audience who are not familiar with Technobase, let me show you a quick video about Technobase and what kind of activities we offer for the rubber industry. Please stand by. Okay, that's about the Technobase. I'm hoping that you understand what Technobase offers. If you need any information, you can always reach out to me. I'd like to request all the participants, in addition to all the participants, if you find this news hour useful to you, I do suggest you to invite your friends, your colleagues, to join this event on every Monday, because a lot of information, we are covering management level issues and also technical issues, a blend of many things that addressing the needs of the rubber industry. Not only you benefit, I also encourage you to invite your colleagues and your friends so that more people benefit, and it's useful for the industry overall. I hope you understand it. I'm hoping that you join me to inviting more of your colleagues and your friends. Thank you for that. If you're unable to join because of the timeline, or if you're busy with the work, you can always watch this program on YouTube channel, Technobit channel. It's available in the next couple of hours time. Once the live session is over, in a few hours it will be available in the YouTube. So you can follow this YouTube channel on the Technobit. Okay, so let's look at today's episode number 7. Let me give you what are the highlights today. Okay, what kind of content is there, what we are presenting to you in this news hour. The first is we are having the natural rubber market review by Mr. Jom Jacob. Okay, and we have a business profile of the introducing 2 companies. We also a couple of other companies part of the rubber industry buyer guide. It's basically a commercial section of the program. And we have Dr. Brendan Rogers. We're having the rubber industry tech talk, focusing on the rubber technology in next decade, what we can expect. And this is a session we have in today's. And we have a rubber industry author talk, and this is by Dr. Hiroshi Mauri. He's retired from the Bridgestone American Center for Research and Technology. We're focusing on the optimized laboratory test condition to predict tire tread wear. His paper was published in the Rubber World magazine, and we're talking about the content of that paper. And we have Mr. Pranab Bhattacharya. He's a well-experienced rubber technologies, giving tips and tricks on the subject called rubber compound and process design to reduce backgrinding. So these are the main highlights of the today's session. I want every one of you to stay on to the end to benefit from this news hour program. Okay, let's get to the first topic and focus on the rubber industry market review. And in this session, we have our guest, Mr. Jom Jacob. He's a rubber industry analyst. He'll be giving a talk on the natural rubber market review. Let me introduce about Mr. Jom Jacob. He's recognized as independent analyst in global rubber industry. He has more than 30 years experience as a global rubber analyst, as a resource expert in conferences, seminars, and workshops. He has extensive knowledge in analyzing the rubber market, forecasting industry trends, and also formulating long-term policies and development plans for the natural rubber sector. And he is well connected from the professionals in businesses involved in the commodity markets, downstream rubber manufacturing, investment banks, hedge funds across the countries. He also served as the association of natural rubber producing countries, we call it ANRPC, as a senior economist for 11 years. He worked with the Rubber Board of India by holding various positions for 23 years, and the Center for Development Studies in India for 2 years as a researcher. So he had extensive experience. He holds a master's in statistics from the Kerala University in India and MPhil in applied economics from Jawaharlal Nehru University in New Delhi. He is also a certified financial technician of the UK-based Society of Technical Analysts. So that's Mr. Jom Jacob. As you see, his extensive experience. We'll be talking about natural rubber market review. Mr. Jom Jacob, please.
Welcome to the NR market review. In the last episode of the NR market review, held last Monday, we made 4 key observations. Number 1, we observed that, or we expected that, rubber futures would be weighed down by geopolitics between Russia and West allies on Ukraine. Number 2, we expected that physical price would gain further, driven by seasonal low supply and improving demand outlook. Improving demand outlook because several countries are reopening international borders. That was the point behind the demand outlook, improving demand outlook. Third observations we made was that rubber futures would rubber futures and physical markets would be following divergent trends. Means futures may be going down and physical may be going down. That means the two will be following divergent trends Fourth observations which we made was that latex market will exhibit greater momentum relative to technically specified rubber or TSR. So let us review what happened last week. Last week was eventful because on last Thursday, that means or 24th of February, Russia invaded Ukraine, setting the beginning of a war. The Western allies retaliated by imposing sanctions against Russia. Russia is world's second largest crude oil producer and gas supplier, especially to Europe. Russia's invasion of Ukraine sends oil prices above $100 a barrel for the first time since 2014 on last Thursday, with the global benchmark which is called a Brent crude oil touching around $105 or $105 per barrel. However, oil prices cooled off and Brent crude oil prices came down to $98 in the subsequent 2 days. In the context of the Ukraine war and the sanctions imposed on Russia, let us examine the significance of Russia in the global rubber industry. How significant is Russia in the global rubber industry? Russia is a major producer and exporter of synthetic rubber. I repeat, producer and exporter of synthetic rubber. Annually, Russia produces 1.6 million tons of synthetic rubber, and it comes to 11% of the global production of synthetic rubber. Russia exports 1.0 million tons of synthetic rubber per year, and this comes to nearly 11% of the total global exports of synthetic rubber. Russia annually consumes 0.7 million tons of synthetic rubber, and this comes to nearly 5% of the total global consumption of synthetic rubber. But Russia consumes very little natural rubber. Annual consumption of natural rubber is only 115,000 tons only. And this is only less than 1% of the total global consumption of natural rubber. That means Russia is an insignificant player in terms of consumption of natural rubber, but not so in the case of production, export, or consumption of synthetic rubber. Moreover, synthetic rubber constitutes 85% of the total consumption of NR plus SR or total rubber in Russia. In the total of NR plus SR consumed in Russia, synthetic rubber constitutes 85%. That means NR share comes to 15% only. Obviously, the sanctions imposed on Russia is likely to impact on SR sector. SR, I mean synthetic rubber sector, rather than NR, natural rubber. The sanctions imposed on Russia can disrupt the supply of SR from Russia. We have to consider that Russia is accounting 11% of the global production of synthetic rubber. The sanctions imposed on Russia can disrupt the supply of SR from Russia. This, together with the soaring oil prices, can make synthetic rubber more expensive. A more expensive synthetic rubber can be an advantage for NR. It can be, but we have to consider the various other aspects also. We will continue on what happens with reference to the Ukraine war. On Saturday, that is February 26, the West allies announced the sweeping new sanctions, including blocking some of the banks from the SWIFT international payment system. SWIFT stands for SWIFT stands for Society for Worldwide Interbank Financial Telecommunications. According to sources in the EU, some 70% of the Russian banking market would be affected by the blocking of SWIFT, SWIFT, the payment system announced by the West allies. 70% of the Russian banking market would be affected by this, by the new sanctions announced by West allies on Saturday. This is something significant. Its immediate consequence. So what is the immediate consequence of this? The Russian banks will no longer be able to make payments for trade and financial activities. This can effectively prevent Russia from exporting commodities such as crude oil, coal, and natural gas. It would also prevent Russia from importing key technologies such as semiconductors and machinery for its own industries. This is one side of the story. But the new sanctions announced on Russia can hit back the West allies. Hit back. The move will disrupt the flow of oil and gas from Russia to other countries. But EU itself depends on Russia for 40% of its natural gas imports. Also, European banks are among the biggest creditors to Russia. The removal of Russia from SWIFT international payment system will leave a question on how Russian banks will make a repayment on its foreign debt. More specifically, the European banks will not be able to receive the debt repayment due from Russian banks. So this is one way how the sanctions are hitting back on the West allies. Also, the move to block Russian banks from SWIFT would disrupt the global trade. That means that this has global impact, ramifications world over. Although crude oil prices cooled off after touching $105 a barrel on Thursday, because oil went up on Thursday and subsequently came down to $95 by within the next 2 days. But the price reached back to $105 by Sunday, that is February 27, in response to the sweeping new economic sanctions announced by the West allies. So Brent crude oil jumped 7% on Sunday, 7% in a single day on Sunday. So what are the implications of the soaring oil prices? The latest round of sanctions will have significant ripple effects on crude oil market. The various banking sanctions make it practically impossible for Russia to trade in petroleum. Most banks will not provide basic financing due to the risk of running foul transactions. The move to block Russian banks from SWIFT international payment system will likely to discourage many buyers from purchasing Russian oil. Russia's invasion of Ukraine will fuel sharper increase in the cost of living by driving up energy prices. When energy prices are going up, already high inflation will heat up further. The extra squeeze on household spending is likely to pull back global economic recovery momentum. That means the high oil prices will heat up inflation further, and that will have negative implications on the global economic recovery momentum. If the global economic recovery is impacted, that means we have to expect negative impact on the demand outlook for natural rubber. That means we cannot say that because oil price is going up, synthetic rubber is going to be more expensive, it's good for natural rubber. That is one side of the story. But we have to take into account the slowing global economic recovery momentum is losing steam, and also it is having negative implications on the demand outlook for natural rubber. So now let us see how NR prices performed last week in key Asian futures and physical markets. We have 6 charts. Let us go to chart number 1. Chart number shows the Shanghai rubber futures during the performance of Shanghai rubber futures during last week. So as we expected, Shanghai rubber futures averaged 1.5% lower during last week compared to a week before. That means Shanghai rubber prices were coming down as we expected. This is mainly Shanghai market is too sensitive to geopolitical tension and also various non-rubber factors. Means Shanghai market is by nature it is more sensitive to factors which are not directly related to supply and demand for natural rubber, but various non-rubber factors, especially the prevailing geopolitical situation. I will go to the second slide, chart number 2. This is the Cyclone TSR20 futures last week. So in the Shanghai, we have seen the prices averaging lower, but in the case of Cyclone TSR20 futures, the price averaged 0.9% higher compared to a week before. One characteristics of the Cyclone market is that Cyclone is compared to Shanghai market, Cyclone market is more reflective of the physical market condition. Means Cyclone market is more sensitive to demand supply fundamental. So this we can see from the chart number 2, which is showing the Cyclone TSR20 prices. Of course, geopolitical situation had an impact. Still, Cyclone market averaged 0.9% higher. Now we go to chart number 3, which is showing the chart number 3. Osaka RSS3 futures averaged 1.3% higher. Osaka market is also more reflective of the supply and demand fundamental, although it is impacted by the geopolitical tension. It is a positive sentiment or tight supply outlook had an impact here, and we have to take into account that Japanese yen was gaining last week. When Japanese yen gains, normally the Osaka futures will be coming down, because when the yen is stronger, investors will be less interested in investing in Japanese in the Osaka futures. But in spite of that negative factor, Osaka futures gained last week, averaged 1.3% higher because of the strong fundamental driven by the seasonal low supply. Now we'll go to the physical markets. Chart number 4. Chart number 4 is comparing, is showing the physical prices of FOB prices of STR20 at Bangkok and SMR20 at Kuala Lumpur. STR20 Bangkok average 1.1% higher, and SMR20 Kuala Lumpur average 2.4% higher. Higher means compared to the previous week. Now we go to chart number 5, which is showing the RSS prices in 2 markets. One is RSS3 physical price at FOB Bangkok, and RSS4 local price at Kottayam markets. RSS3 Bangkok averaged 3.6% higher during last week compared to a week before. And RSS4 Kottayam, it was falling down the previous week, but this week it averaged 1.2% higher compared to a week before. In Indian market, tech companies are largely staying away, but they have started buying because now Indian market is gaining because of the global Q, means because of the global uptrend, Indian market also going up. And we have one more slide, chart number 6, which is comparing the latest prices, physical prices of latex at Bangkok and also at Kuala Lumpur market. At Kuala Lumpur markets, latest prices average 8.6% higher, means see 8.6% higher compared to a week before. In the case of Kuala Lumpur SMR 20, as we rightly expected, it was the SMR 20, the increase in the case of SMR 20 was high, considerably lower. But in the case of latex, it is the average, it's average 8.6% higher. When we go to the latex market in Bangkok, it's averaged 4.2% higher. So as we expected, latex performed better relative to STR in both the physical markets. Now we will continue. So looking ahead, what lies ahead? Rubber futures, especially the Shanghai rubber futures, are unlikely to gain in the coming week because investors are expected to keep away in view of the risk and uncertainties. Speculative investors, when there is a risk and uncertainties, they will keep away from risky portfolios. Normally, they will be keeping away from risky portfolios, and they'll be rushing towards safe haven. Safe haven, it could be currencies or gold. Safe haven currencies are US dollar, yen, Swiss franc, and gold also is another safe haven. So this is a usual trend. So we are not expecting a gain in the rubber futures, especially in the Shanghai rubber futures in the coming week. But in the case of but SICOM and Osaka exchange need not follow the trend at the Shanghai rubber futures. And second observation and our second expectation for the next week, physical prices can receive the support from the seasonal low supply, because world over the global supply of natural rubber is expected to remain low because of the seasonal wintering of rubber trees, and supply will remain low. But the supply is remaining low, that is one side, but the outlook on demand is expected to come down. So we are expecting some kind of a trimmed demand outlook. Even if the physical market can gain, the supported by seasonal low supply, the gains will be marginal. This is due to the potential negative impact on the demand outlook. As we mentioned earlier, the soaring oil prices and the heating inflation will impact on the purchasing power of the people. The spending will be affected because the household spending will be affected because of higher living costs, and this will have some negative impact on the global economic outlook. And a negative global economic outlook means we can expect some kind of downward revision of the global demand for natural rubber. So coming week, we are expecting some kind of a downward revision of the global demand outlook for natural rubber. At the same time, the supply side is positive because of the seasonal low supply. The global supply of natural rubber will be low. So we have low supply, but at the same time, the demand side, we are not strong. So this is something we are expecting. That means physical market can gain in the coming week. Even if it is gaining, the gain will be limited. That is our observation. And SICOM and Osaka exchanges are expected to perform better than Shanghai Futures Exchange. Shanghai is more sensitive to non-fundamental factors, but SICOM and Osaka futures are likely to reflect the development in the physical market. We are not expecting a fall in the physical market. Physical market is likely to be a little bit neutral or marginally lower or marginally higher. Roughly we can say we are expecting a sideways movement. That's all about the expectation for the next week. We will see again next Monday at the same time. Thank you very much.
Okay, thank you very much, Mr. June Jacob, for sharing your insights on the natural rubber market review. As you may know, I'd like to introduce about one of the program managed and hosted by Mr. June Jacob. It's called NR Dialogue. That is episode number 3. This episode is focusing on the Latin America natural rubber industry. We have invited 3 specialized professionals from Brazil, Latin America. So they will be discussing about the challenges, opportunities in the Latin American NR market. So I do invite all of you to participate in this program on the 24th of March. It's also same time, 9:30 p.m. Singapore, 7 p.m. India, but in Brazil time is 10:30. This is schedule. Okay. Okay, let's move on to the rubber industry business profile. As you know, this is basically a program, a commercial part of this rubber industry news hour. In this rubber industry business profile, we introduce companies about their products and services. I'm pleased to introduce the first company is the Technovaxchem and also the Rasha Chemicals. They are recognized as the one-stop outlet for the specialty rubber chemicals. Let's look at their products and profile about the services as well. Okay. A short video on this company, please. Okay, that's about the presentation on the Technovaxchem, one-stop outlet for specialty rubber chemicals. If you are looking for a specialty rubber chemicals, you should reach out to the Technovaxchem or the Rasha Chemicals. Okay, now I should introduce about other company called the Wholewell Components, which is called the one-stop solution for all elastomeric needs. Let's look at the Wholewell Components products and services. that's about the whole well components. If you're looking for their assistance or interested in their products, you can reach out to them. This whole well components is a one-stop solution for all elastomeric needs. Okay, now we move to the next part of the session that is called the Rubber Industry Tech Talk. In this session, we have Dr. Brendan Rogers. He is the well-experienced rubber technologist. We'll be discussing about the rubber technology in next decade, what we can expect. Let me brief you about Dr. Brendan Rogers. He has spent 42 years working in the tire and rubber industry with both the Goodyear Tire and Rubber Company and ExxonMobil. He has worked on a broad range of tire and industrial rubber products, including hydraulic hoses, conveyor belts, materials technology, and product design. He has had work assignments in the US, China, Ireland, Italy, Luxembourg, working on OEM tires, truck tires, industrial rubber products, and new tire materials technology. He is originator of a broad range of patents in tire and rubber technology and many industrial publications, including hydraulic text, rubber compounding, chemistry, and applications. And also there is a book on tire engineering, both published by CRC Press. He has a PhD in chemical engineering from the Queen's University of Belfast in North Ireland, where he studied on thermodynamics, heat transfer through large rubber sections and the vulcanization kinetics. I'm pleased to see you introduce these books. I think if you're interested in any of the, these are very good books published by the CRC Press, written by Dr. Brendan Rogers, Tire Engineering and Introduction, and the second book is the Rubber Compounding, Chemistry and Applications. So please check the website of CRC Press. You may find this and how to order it. Okay? Dr. Brendan Rogers also contributed a number of know-how webinars belong to the Technobase. One is a tire inner liner and butyl rubbers, natural rubber grades and selection, radial tire compound polymer blends, aircraft tire materials technology, and also tire curing ladder. If you're interested in these know-how webinars, you can reach to the website know-how-webinars.com. So let's welcome Dr. Brendan Rogers to come on board to discuss about what is the future of the rubber technology in the next decade and what we can expect. Dr. Brendan, welcome to the program.
Yeah, thank you for the invitation.
So let's get started, Dr. Brendan, on various issues we'd like to talk about. So as your experience and more than 40 years experience both in the tire technology as well as the industrial rubber products, what kind of technology trend that you may foresee, in the tire and as well as industrial rubber products?
Okay, yeah. When we look at the industry, first of all, I should say that if we exclude products like the iPhone and things like that, just focus on the automotive and transportation industry, probably I would say the most complex composite product in mass production today is a tire. So when we look at that complexity of that product, and then look at the typical trends we see journalists discuss in magazines and other publications, you can basically cut those into three macroeconomic trends. First of all, I see a lot more consolidation within the tire industry, particularly in Asia. That consolidation is going to be driven by really three things. Competition. There are too many tire companies, to put it that way. The need for better quality. I can't emphasize that enough. Quality is going to be a key driver on how companies will consolidate. And then the third thing is the government guidance. Governments love the tire industry and the industrial rubber products industry for one key reason, that it's not only labor intensive, but it employs a lot of skilled labor. And in order for that industry to survive, the technology base will have to improve. And to do that is going to necessitate consolidation. So that's probably the first thing in that area. Second, materials. For example, we're seeing a lot of new technology compounds coming in, particularly in the passenger tire market. Things like these ultra high silica level tread compounds that could have potential detrimental impact on overall tire factory productivity and throughput rates, and to bring those compounds in to meet the fuel economy or the rolling resistance trends that are needed. We need to make sure there's no detrimental impact on treadwear or tire removal mileage. That's going to be a challenge. Under the materials category, I also see another area emerging in the next few years, and that is with all the new gas coming online around the world, there's an excess of methane, ethane, and propane, the C2s and 3Cs. With that low feedstock, I can see some new elastomers being developed to capture that, again, low-cost feedstock, either through dimerization of things like ethane to ethylene to and dimerizing to butadiene and so on, or polymers of that nature. The third area, again, the macroeconomic area I see is cost. This is going to be a challenge. Materials costs, Job had mentioned this in the previous discussion on natural rubber, costs are trending upwards. So we see materials going up, manufacturing conversion costs, that's from raw materials in at one end to the tire rod at the other, or conveyor belt or whatever. Those costs are going up. So when we look at the overall trend, again, at the macro level, if we go back 20 years or 25 years, the overall cost to make something like a tire was around 50% raw materials, 25% conversion costs, and 25% overhead. Today, we see that shifting more to an 80% raw materials, 10% conversion, 10% overhead. So materials are taking a bigger chunk of the overall cost to build a tire, and that's going to create challenges for the industry going forward. So in terms of the macroeconomic major trends, I see consolidation as number one, materials, and then third, costs, overall cost to manufacture. They're the three big things I see in the next 4 or 5 years.
Okay. How about automation side? What kind of changes is happening in automation when it comes to the?
Oh yeah, automation. That is well, really. When you look at automation, we've got to put that in the context of the other trends that are occurring. And there I see probably 5 things happening. First of all, non-pneumatic tires, they're going to continue to be a niche market. So I see the pneumatic tire, that's not going to change. That'll be around with us for another 10, 15, 20 years. So I don't see any change there. But the non-pneumatic, and again, this all ties back to automation. The non-pneumatic tire will only be in the niche markets like on off-road, skid steers, that type of application. The pneumatic tire will stay with us for one key reason, and that is to change will necessitate changing the vehicle cornering suspension system to compensate for the change in damping characteristics of the non-pneumatic tire. So the air is going to stay with us. How does that ties into manufacturing, automation? Certainly that will increase. The amount of level of automation will increase, and we'll see robotic building systems. The VMI Max system is part of the benchmark in that regard. The automated mixing systems and so on. So automation will increase. The issue with automation is going to be efficiency and agility. So on one hand, yes, it's more efficient if you have long runs of one specification, but with the changing of the diversity, I guess you could put it that way, and the number of tire sizes, designs, and so on, run lengths tend to be shorter, and the automated manufacturing systems don't really lend themselves to the shorter run cycles in the manufacturing plant. That shorter run cycles is going to be compounded more by, for example, tires for electric vehicles. That's going to create another set of challenges for the industry. So load carrying capacity of the tire will have to be improved. Tire reliability will have to be improved because of the removal of the spare tire, for example, to get the weight down on the vehicle. And then one challenge I see the industry is going to have to confront with is less emphasis on rolling resistance per se, because that is a one point in time test number, but more on in-service energy losses for the vehicle. So for example, for an internal combustion engine ICG vehicle, around 7% of the energy consumption for a car is attributable to tire rolling resistance. When you go to an EV, like a Tesla or something like that, that 7% becomes up to 35%. So the energy losses due to the tire in an electric vehicle are a factor of 4, maybe 5 times greater than an internal combustion engine powered system. So that's going to be a challenge in meeting that. Modeling is certainly in the trend. That's one of the key trends. We see more and more emphasis on modeling. I tend to come from the school of you can never have enough data. So certainly modeling allows us to screen more options for before going into an experimental tire build, for example. But we still need to validate the model on the road with real-world testing. What modeling does allow, however, is an improvement in the quality of the decisions that are made in a new development program. And that is of paramount importance. Improving the quality of the decision making is critical, and modeling allows us to do that. In that broad area of automation, I see another opportunity going forward into the future, and that it really is, I guess, somewhat different, but in the sense of tire R&D management structures. I've seen some very efficient management structures, highly productive working environments, and I've also seen environments which lend themselves to improvement. I think this area needs a lot of work going forward, for it will have a big impact on the industry's ability to meet the challenges going forward, such as automation, developing tires for EV applications, the non-pneumatic tire, which is going into the more on-off road applications. Again, reliability is going to be the big benefit there. And then, of course, like as we mentioned, automation. How do we bring in more automated plants and manage that in an efficient and productive manner? So it's a lot of challenges going forward into the future, and I certainly see automation is going to be a critical element in that. If we can also bring in systems which are sufficiently agile at the same time.
So how about the non-tire components, non-tire, whether it's OEM or automotive, and also the non-automotive products? What kind of changes you can expect in terms of the technology and material?
Yeah, good question. Certainly, when we look at the trends of what has happened previously, the under the hood operating temperatures have increased, and that's driven us away from use of polymers such as polychloroprene, the neoprenes, more to hoses being made from EPDM, so we have a better heat resistance and so on. That's all driven by the aerodynamics. Certainly, I would see that continuing. The big challenge confronting the hose manufacturers for automotive applications is going to be adhesion, EPDM, compound adhesion to the adjacent components and something like the hose, or the composite structure of transmission belts. The adhesion is a big challenge there, and that still remains an issue. Some of the adhesion technology, resin technology that has been used to improve component-to-component adhesion in belts and hoses has certainly contributed. The dicyclopentadiene resins have proved to be very effective at building good tack when the hoses are being built, and so on. In the larger products, like industrial products, conveyor belts, some of the same issues there. The durability is going to be the big one. I see the conveyor belt market potentially improving. We came across, worked in one project in Chile, for example, where moving product sometimes up to 40 kilometers is much more effective on a conveyor belt system rather than trucks. So trucks more expensive. The tires extremely expensive on those 200, 300-ton trucks, big Lobbys Caterpillar trucks. Conveyor belt systems can be much more efficient at moving that product. So not only has it a lower environmental footprint, but the overall efficiency and cost of the installation, again, is much more effective. So yeah, with regard to the environmental impact, I probably see three things here. The number one would be, well, the three things are really going to be around pollution, climate change, and sustainability. I think pollution is going to be always an issue for every responsible tire manufacturer or industrial products manufacturer, in the sense that the processes and the manufacturing facilities must be designed to handle waste, both the post-industrial waste, that's scrap coming out of the plant, and then the post-consumer. You know, what do we do with all the waste rubber products once at the end of their service lives? And tire recycling is going to be probably the biggest challenge at the moment. But efforts to address the post-industrial and post-consumer waste, that has to continue, especially in the areas of recycling. And a lot more work needs to be done there. That will be an ongoing area. Climate change is always an issue. The United Nations has published another report which has raised this issue again, but at the macro level. But at the micro level, what can we do as scientists and engineers in the manufacturing of industrial rubber products and tires? I think that really brings us into the whole area of sustainability. And sustainability has had a lot of rhetoric and claims around it, but I think we need to convert sustainability into a hard science. It gives us an opportunity to put some hard engineering and technology into the debate, and that's going to be essential. It's going to be really important. I think the oil and gas industry has done a superb job at addressing this whole issue around sustainability. I did a study on this, and basically you can break this into 10 items. If I could just take some time to walk through that very quickly. Probably the most important is safety. And safety in tire manufacturing plants and industrial product plants is crucial. It's critical. A safe working environment is essential for all our workers in that environment, and the end users of our products as well. They have to be safe, reliable, and every effort taken to ensure that there's no risk of early product failure. Water conservation would be the second item in this one. Water is an issue all over the world, so water conservation, recycling. I've seen numbers in tire factories, some of the larger tire factories needing up to 7,000 to 12,000 liters of makeup water for every ton of product that's coming out of the plant. That's a lot of water. Power and energy efficiency, that's always an issue. Emissions, we want a zero emissions plant is the ideal. Materials conversion, the ideal is for every molecule of carbon coming in at one end of the plant goes out as a final product at the other end. It's the ideal. Equipment reliability, the preventative maintenance programs and overall efficiencies in the plant have a big impact on productivity. I think we'll see more effort in recycling, particularly within the manufacturing sector of our industry. That falls under that broad category of post-industrial scrap that we talked about, and that's the compounds, reinforcements, or the tires, for example, not passing the final inspection. How do we do that? How do we handle that scrap? Will always continue to be an issue. And then the secondary pollution controls. Pollution, again, is a sensitive issue. Secondary pollution controls, that's what do we do with pallets, wooden pallets, cardboard packaging disposal, excess chemical inventories. toxic materials, how do we handle those, particularly the volatile organic compounds, and then mold, flash, and trim that comes off the final inspection areas. So that's secondary pollution. Those issues need to be addressed. And then, of course, probably more important is the social awareness, the employee involvement, employee engagement, and in the company, the community commitment, because companies can only exist with the consent of the community at the end of the day. And then what does the enterprise contribute to society? So, so when we step back and look at the, the business environment we're operating in, pollution, climate change, sustainability, I'd say sustainability is of paramount importance, but we need to convert that into a hard engineering and technology science moving forward. So that is probably one of the bigger challenges to see this for the industry as a whole going forward.
How about what is your opinion about the recovered carbon black? We call RCB.
Oh, recovered carbon, yeah.
Yeah. So what is your opinion? I think many companies, many big tire companies talking about, okay, they use a 70% sustainable material. Some are going forward 100% sustainable materials. Yeah. I think one product is in a recovered carbon black. What is your impression or opinion on this?
Yeah, that is an area which you tend to see mixed signals in this one. The research and development work has to continue because we want to recycle. The ideal is recycle the products back into new products. And there's a lot of carbon in a tire, for example, that can be captured. The quality of the material is going to be of the utmost importance, because if we look at original carbon black, if, for example, we shift grade from an N121 to an N330 in a tread compound, that will have a big impact on tread wear, ballast to removal, enormous impact on a passenger tire or a truck tire. When we look at recycled carbon, that has to be produced to the same quality as we have with the original carbon blacks, and I don't think we're there yet. That's got a ways to go. Having said that, it can still be used, blended in at certain levels that will not have a detrimental impact on the end product performance. So there's more work to be done there. In terms of meeting the technical standards that are needed in order for it to be competitive with original black. And then part of the second area in that broad topic is the environmental impact on the manufacturing plant for the recycled. So the facility that is used to extract these materials from vulcanized products, there's a lot of pollution associated with those plants, and that would need to be addressed from that perspective. So it's the two areas: one, meeting the technical specs, and two is the environmental impact of the recycling plants.
What is your comment on this wearing out of tires, contaminating the earth and environment in large proportions, when you use for a long time these tires?
The fines from
carbon
black.
The wearing of when the tire gets wear, a lot of particles, tire particles.
Particulate matter, yes. Yeah. Okay, yes, I believe that is attracting a lot of attention in Europe at the moment, is the particulate matter coming from worn tires. That's another more work needs to be done there. I think when we look at treadwear, which is where the bulk of the material would come from, basically treadwear is essentially one of two processes. One is when you cut to the basics, a thermo-oxidative degradation. So I guess to be overly simplistic, the tread compound would be vaporized, or it can be a tensile tearing mechanism where we predominantly the particulate matter would emerge from. That tensile tearing mechanism, we'd have small particles which could be end up in the water streams, which I think is what the primary concern is. I think that's going to be with us. The industry is working on it. We don't really have a clear solution to a clear solution to the problem. We're still collecting data from the just last week. This came up, and very much we're in a data collection area. I think we're still waiting to see what emerges.
That is one serious concern as well in an environmental perspective. Dr. Brendan, thank you very much, for joining and sharing us insights into what we can expect, challenges involved in the rubber technology. Before I let you go, you've been a consultant after retiring, and can you explain or give more information on what kind of consulting services you've been offering, so that the audience would be interested to take your assistance for their projects or the product development, please.
Oh yeah, thank you. Well, essentially, we've been working on one big project, which has been really exciting. It's been on graphene. That project is graphene goes back to around 2004 when it was first invented. It was expensive, but the new grades, the new technologies that have emerged over the last few years, the price has come down enormously, and now it's come to the point where it is feasible to consider it in, for example, high-performance products. It improves things like tear strength, abrasion resistance, the component-to-component adhesion, which is very important in a tire. It can improve hysteresis, better fuel economy, and all without any loss in other properties. For example, it can be a drop-in in many compounds, such as a truck tire tread compound. So that's been one very exciting project. I think it's got an enormous amount of potential, particularly in tires such as, for example, aircraft tires, where not only do we need good heat resistance, aircraft landings, for example, but also good abrasion resistance, and work very effectively in products like an aircraft tire tread. So that's one very exciting project. Also been doing other projects on butyl polymers to improve impermeability, adding additives to butyl to, again, give better air retention qualities, or reduce permeability in, for example, applications such as masks, face masks, and that sort of thing. Yeah. So some exciting projects there that are in place at the moment.
Yeah, thank you, Dr. Brendan, for joining this session and giving all the insights into the program. I know rubber technology and its future. As I mentioned to all of you, Dr. Brendan is a consultant. If you're looking, some assistance, he's specialized with a huge experience on the compound development, both on the tire technology, and also the industrial rubber products. So you can reach out either to us or, to Dr. Brendan directly. Once again, Dr. Brendan, thank you very much.
Thank you.
See you in the next session. So thank you very much. Bye. Okay, that's the session on the rubber industry tech talk, focusing on the rubber technology in next decade, what we can expect. I'm sure that you find it very useful, where Dr. Brendan has given you lots of opportunities and challenges involved in both on the tire technology as well as the non-tire technology as well. Okay, let's move to the next part of the program, that is a rubber industry buyer guide. This is a commercial part of this rubber industry NewsHour. This is basically a source guide for the rubber industries, in whether it's rubber chemicals, machinery, or various rubber materials or other services. So let me show you a short video on the rubber industry buyer guide. Okay, that's the rubber industry buyer guide. I do encourage all of you to reach out to these companies if you're interested in their products or services. So you can check it out, their websites, and on the rubber industry buyer guide. Now, the next part of the program is a rubber industry author talk. This is a new addition to the rubber industry news server. The component of rubber industry author talk is basically we invite authors who publish papers in reputed journals or magazines about the rubber technology or rubber developments. So we ask them to talk about their published papers. So in this today session, we have Dr. Hiroshi Mori, retired as a president of the Bridgestone America Center for Research and Technology. He has published a paper on the optimized laboratory test condition to predict tire tread wear. This paper was published in a Rubber World magazine in January 2022. I do encourage all of you to subscribe this Rubber World magazine, one of the best technical magazine. You find a lot of useful information. You go to rubberworld.com, you can subscribe that magazine, and also you download this paper, which is January 2022, 2 months ago, okay, published in that issue. Okay, let's we talk about this paper. Okay, let me start the presentation on this paper. Hello, Mr. Hiroshi Mori-san. Welcome to the Rubber Industry Author Talk. Thank you for accepting our invitation to be part of this program on the Rubber Industry Author Talk. Basically, in this Author Talk, we introduce authors who publish papers in our magazines or research journals to talk about their work. So welcome to the this session today.
Okay, thank you.
Thank you very much. So before we get into your paper, what we are going to discuss on the optimized laboratory test condition to predict tire tread wear, I'd like to get to know more about your experience, your background. Can you please share us how was your experience so far?
Okay, thank you for the invitation first. My name is Hiroshi Mori, and I have a PhD from Tokyo Institute of Technology, and I worked at Bridgestone for 40 years, and 40. Bridgestone is known as the largest tire company in the world, as you may know. And I worked as a scientist for a long time, and at the last work was as a president of the Bridgestone America Center for Research and Technology. That's in the United States. And I retired at the end of 2019, right before the pandemic. My plan was to travel around the world, but obviously I had to change my plans, and I stay home and work as a rubber consultant. That's briefly my background, and I give lectures at universities, and I help university students. I also do work for ISO, the rubber testing, which is TC45.
Yeah.
So that's about my background.
And so you lived in Japan, or you lived in the US, or which places you work in for Bridgestone?
I live in Tokyo, Japan. I moved back in 2014.
I see. And your main research work is as a scientist. What is your role? You work on what kind of activities you do at the Bridgestone?
Well, I worked on all kinds of things, from natural rubber, synthetic rubber, tire rubber, and tire ingredients. Almost everything. 40 years is a long time.
That's right. Yeah. So you covered You can say they were Mr. Tire Technologist, or you can say encyclopedia for the on the tire technology from the Bridgestone.
Yeah, walking encyclopedia.
Walking encyclopedia. That's the right word. Thank you. Nice. That's nice to know about you, Seth. Thank you for joining. Okay, so today, I'd like to invite you to talk about your paper on the optimized laboratory test condition to predict tire tread wear. Please give us, what is the main content of this paper? What is it been, advise readers to what they look for, how it benefits them. Okay. Let me open the file for you. Okay. Yes, please go ahead.
Okay, the title of my talk or my paper is Optimized Laboratory Test Condition to Predict Tire Tread Wear. And this paper was first published in a Japanese paper, Nippon Gomu Kyokaishi, and 4 months later it was published in Rubber World early this year. Next slide, please. Oh, I have the control. Okay, so I'll talk about history. Laboratory tread wear test was developed almost a century ago by Leonardo Lamborn, and known as the Lamborn abrasion test. And you have a test wheel, which is a rubber sample. You rotate it against the abrasive wheel at a different speed. And you can see a decent correlation between tire wear resistance and laboratory wear test result. But this is fourfold difference, and practically when you want to see 20-30% difference, you might want a better prediction. So the next slide is about the changing wear mechanism. Well, 100 years is a long time, and there was a lot of change in the world. Of course, the vehicles were nicer, and they were lighter and have better performance and better alignment, and roads are a lot smoother. The tires were significantly improved too, from bias tire to a radial tire. So there's a lot of changing wear mechanism. Wear mechanism used to be elastic wear, where you see a wear pattern that is perpendicular to the direction of traveling. As you go to milder wear, the abrasion pattern gets smaller. And this is called elastic wear, but eventually this wear pattern gets so small that you can't see it. It disappears. And Alan Weiss of Goodrich, he called this a plastic wear or P-wear. So how do we test this low severity wear? Next slide. We use the FPS wear tester model AB 2012 by Ueshima. And this machine is specially designed to fit the needs for low slip ratio test, low severity test. So the repeatability is within 5%, and this is the most important aspect of low severity testing, because a small change in slip ratio can change the results significantly. And also this has a semi-automatic system, and I want to show you a short video. So since the machine automatically changes the sample, you don't need to be with the machine all the time. You just load samples, push the button, go home, and come back the next day, and you have the test results. And here the wear test begins. All and it ends automatically. So this is a brief explanation of the tester and how do we determine the slip ratio of a low severity test. This is an acceleration distribution of a vehicle. The right side is deceleration, as in the left side is acceleration. You see a big peak right around 0, and this is due to constant speed driving or due to tire rolling resistance. You see a second peak around 0.4 G. This is due to braking, and this is the main driver for wear. This big peak around 0 does not contribute to wear at all. So 0.4 G deceleration is equivalent to a friction coefficient of 0.4, the same thing. So if you look at 0.4 friction coefficient on a slip ratio versus friction coefficient relationship, you see the slip ratio is %. We can skip this one. It's in the paper. So the last slide is optimum laboratory wear condition for passenger tires. Load is about 10 to 15 Newton. Slip ratio, as I show, was 3 to 5%. Speed is 100 to 200 meters per minute, and the pavement is 240 mesh. And the correlation between FPS wear test and the tire wear test, you see a decent correlation in spite of the narrow range that I tested. So you can also find optimum conditions for heavy-duty truck tires in the paper. And that's all I have. Thank you for your attention.
Yep. Thank you very much, Mr. Hiroshi-san. Appreciate the contribution on the paper. It's a very useful paper for the tire industries. I'm sure that I encourage all the audience to go to the rubberworld.com to read. You can download this magazine. Actually, it's a free digital edition. Is a free to subscribe, and you can download it and you can read this full paper on the optimized laboratory test condition to predict tire tread wear. Thank you very much, Hiroshi-san. Before I let you go, because you are with 40 plus years in the tire industry, I'd like to ask you whether you can give some advice to the younger generation who wants to enter into the tire industry, how to be there, how to sustain, in the tire industry, please.
Oh, there's a lot of up and downs during the long time.
Yeah.
So you just have to be patient and not, stay there as long as you can. And then you learn something.
Right.
Maybe that's the way to go.
That's the way to go. And also, then you also, a lot of changes happening on the EV and electric vehicles are coming in. So what kind of research is developing towards a tire design? Any like to give some input on it? And because you've been there 40 years, I'd like to utilize this opportunity to give some insights on the electric vehicle development. I think it's all world is exploding into the EVs. Yeah. So yeah.
Well, electric vehicle, you don't have an engine. It's driven by a motor. So it's very silent. And the tire noise is going to be the main contributor for the overall noise. And I'm not sure if you want to reduce tire noise further, because you don't want a car that's approaching silently. You want to know that the car is approaching as a pedestrian. So I don't know if this is a requirement, but obviously the car manufacturers are asking to reduce noise. And tire rolling resistance and tire wear resistance, they will emphasize more in the future.
Okay.
Is that okay?
That's fine. Thank you very much. Thank you very much. Once again, I thank you for joining this session today, and I'm hoping to invite you in more sessions in the near future as it fits to you, as convenient to all of us. Yeah, thank you very much. Yeah.
You're welcome and thank you.
So, guys, that's the the rubber industry other talk on the topic on the optimize laboratory test condition to predict tire tread weight. I do recommend all of you to go to the rubberworld.com. You can download the this paper if you're interested in this subject. Okay, now let's move to the next session of this rubber industry tips and tricks. This is very useful for the people in the industry who want to improve their process. And we have invited various experts to talk about these tips and tricks. With the huge experience, they're sharing some of their the tricks and tips and tricks in this session. Today, we are covering on the topic on the rubber compound and process design to reduce backgrinding. And this session is taken by Mr. Pranab K. Bhattacharya. Let me brief about Mr. Bhattacharya. He is a well-experienced rubber technologist with close to 28 years experience. Currently, he is working as a technical manager at JMF Synthetics, India. He got a rich expertise in the adhesion science and technology for plastics and rubber to metal bond composites. And his major expertise involved material selection and a new product development by designing compound in general purpose as well as the specialty purpose rubbers. He has worked with a number of companies like Jayashree Polymers, Ramaco Overseas, ACE, Volcom, with Elastomer Processor, Suzanne Group, Premier Sales. So Mr. Pranab is sharing his experience into the tips and tricks session. Just give additional information. He also contributed the NewsHour webinar, one on focusing on the rubber to metal bonding, case studies and troubleshooting. And also, I think like today's tips and tricks, he did in the past sessions, EPDM rubber compounding. If you check our rubber industry NewsHour, you'll find this session on the tips and tricks focusing on the EPDM rubber compounding. Okay, let's look at the the presentation on the rubber compound and process design to reduce backgrinding.
Hello everyone. Welcome to Tips and Tricks session of NewsHour, an initiative by Technobiz. In this session, I'll talk about rubber compound and process design to reduce backgrinding. Rubbers are vulcanized or cured inside the mold through the method of compression, transfer, and injection molding. Molds contain 2 or more plates, and parting lines are generated on final products. A thin, uniform parting line on molded components is the requirement. However, many a times during processing, the parting lines are found to be non-uniform, wavy, and foamy in nature. During deflation, these parting lines are torn and produces cracks. This defect is known as backrinding. So what is backrinding? Backrinding is a molding defect, appears as a rough edge observed on parting line during molding of elastomeric components. Scorched foamy rubber generates on the mold line during flash removal. This scorched and foamy rubber propagates cracks on the product across the mold parting line. This results in a defective product. What is the plausible reason of backrending? During molding, the mold is kept inside molding press at higher temperature for vulcanizations. In case of compression molding, preformed blank of mixed rubber is kept inside the mold cavity directly, and pressure is applied at high temperature through molding press. In case of transfer molding, the rubber is kept inside a transfer pot and pressure is applied through a plunger so that rubber can flow inside the cavity through transfer holes. In both cases, rubber transforms from semi-solid to liquid or semi-solid state inside the core cavity. This liquid or semi-liquid inside the core cavity is incompressible in nature. The mold is heated, and under heat, the liquid of the core expands, that is thermal expansion takes place. Due to this thermal expansion, the liquid flows and applies tremendous pressures on the mold. The pressures sometimes sufficient enough to open up the mold on its putting line to allow the molten rubber to flow inside the cavity. But the heat history of the rubber adjacent to putting line is different. It may so happen that rubber adjacent to putting line is permanently, partially cured or scorched. If the ejected polymer is partially scorched, then flaws appears on putting line, and this is known as backrend. So the plausible reason of backrending is thermal expansion forces partially cured rubber out of the mold, and uneven wavy surface generates on putting line. This is essentially an imbalance in rate of cure between the surface and the core material. However, backrending may also be caused by bars or roughness of the mold on the putting edges or excessive mold openings. How to characterize the compounds to assess backrending? 4 important compound and process characteristics can be considered to assess the backrending of compounds. The first one is the minimum torque or ml values of the compound. This we can get it from rheometer. Second one is the scorch time, TS5 of the compound. Again, this we can get it from rheometer. Time taken to travel the rubber from the bottom to putting lines. This is very difficult to assess in conventional rubber industries. The fourth one is Muni viscosity of the compound. So out of the 4 parameters, 3 parameters is measurable, and these 3 parameters can be used to assess the backrending capabilities of the compounds. A very low ml values can generate backrending. Also, too high ml values can also be responsible for backrending, associated with other molding defects related to mold filling. So we need an optimum ml or Muni viscosity of compound. This needs to be studied and standardized by change in mixing parameters of the compound mixing. So mixing sequence and mixing parameters have equally important part on backrending. The more the scorch time, the better is the safety of the compound, and the lower is the tendency to backrending. Is there any effect of type of rubber on backrending? Backrending may occur in any kind of elastomers, especially if the item is thick. It is compound, process, and product specific. Compound, when processed differently, may reduce the backrending effect. Also, the same compound and same process might generate backrending if the component differs in size and geometry. Tendency towards backrending can be assessed with regard to polymer. It can be generalized based on thermal expansion behavior coupled with the cure characteristics. Tendency towards backrending can follow an order. ACM and FKM compound has the highest tendency towards backrending. Next comes silicon. Peroxycure NBR and peroxycure EPDM has higher tendency of backrending compared to sulfur cure EPDM, and sulfur cure general purpose rubber has the lowest tendency to backrending. Now, we will briefly discuss on factors to control backrending on different type of compound. First one is controlling backrending in ACM compound. Polyacrylic rubbers are made from different acrylic monomers with different molecular weight to adjust oil resistant and low temperature properties. Conventionally, general purpose and high heat resistant grades are available. ACM rubber contains different cure sites and different cure systems are used to manufacture molded goods. Commonly used cure sites are epoxy cure sites, chlorine cure sites, carboxyl cure sites, and dual system of carboxyl and chlorine cure sites. Nowadays, epoxy cure systems are used less, and ACM with chlorine cure sites are widely used for general purpose molded ACM components. In chlorine cure sites, triazine cure system and soap sulfur cure systems are mostly used. Triazine cure systems offers faster cure rate, but with reduced scorch safety. Considering the better process safety of soap sulfur cure system, the triazine cure system can be switched to soap sulfur cure system to reduce backrending if observed on components. Stearic acid is often added inside the compound. This acts not only as an effective process aid, but also as a retarder with most cure system used in ACM rubber. So an overall balance of stearic acid with certain process aid needs to be obtained to reduce the backrending. Cure chemicals like potassium stearate and sodium stearate contains moisture and difficult to disperse. Some amount of moisture level helps in dispersion. So choice of proper quality of sodium and potassium stearate is required to reduce backrending. time and temperature of mixing inside the kneader is required for achieving optimum ml and monoviscosity to reduce backrending. Mixing of SCM rubber is very important to control monoviscosity and minimum torque values. Master batch is advisable to be mixed in kneader. The time of mixing and dump temperature should be standardized. The master batch needs to be cooled down, and final mixing should be done in cold mill in two-roll mixing mill. Variations of mixing procedure will change the viscosity and thermal expansion behavior, along with the change in cure characteristics, leading to defects like backrending on the molded product. Another aspect of SCM rubber is that polyacrylic compounds with carbon black reinforcement gives the appearance of scorch upon beam aging, that is during storage. This beam aging can generate higher backrend defect. It is advisable to check the monoviscosity of compound before use. And if the viscosity rise is more than 10 units, the compound is scorched and cannot be used. It will definitely generate backrending along with other molding defects. However, if the rise in viscosity is less than 10 units or minimal, then remilling in cold mixing mill can refresh the compound. Next, I will come on controlling backrending in bisphenol cured FKM compound. The major difference of FKM is the higher thermal expansion than most rubbers. This higher thermal expansion of core cavity or core rubber exerts force on pre-cured rubber on the surface, resulting in backrending. This is prominent even in preparation of 12.5 mm thick compression set buttons for testing. During preparations of compression button, especially if it is a 3-plate mold containing 2 plain top and bottom plates and core cavity in middle, the flash in one plain plate often shows backrending defect, but the flash line adjacent to other plate does not contain any backrend. Similarly, in components with 2 parting lines, it is observed that backrending effect is prominent in one side of the parting line, but the other side of the parting line is smooth and uniform. Typically, for curing, 6 pH of calcium hydroxide and 3 parts of magnesium oxides are used. Different ratios can be used with 3 pH of calcium hydroxide and 6 parts of magnesium oxide for better bonding to metal inserts. The entire cure system is used in conjunction with the metal oxides, which acts as acid acceptors in all systems, capturing hydrogen fluoride formed during vulcanization. To avoid backrending, we need better scorch safety. A few actions can be taken to reduce or eliminate backrending. Addition of few parts of calcium oxide in compound can help in reducing backrending. In case of compression or transfer molding, preformed or blanks should be warmed before use. Simple example is preparation of compression set button. If we prepare the cylindrical blank by rolling a thin sheet from one mixing mill, followed by cutting in required weight, and fill the cavities in cylindrical preform, in one condition, tendency of backrending is reduced drastically. Temperature of molding can be reduced for effective slow curing and better scorch safety. Next is controlling backrending in epoxy or silicon rubber. Silicon rubber in epoxy pure system during compression or even in 3 plates or 4 plates transfer molds generates backrending across the flash line. So we need to select a suitable grade, preferably with low thermal expansion. If compression molding preforms, they should be heated and they should be approximately the shape of the mold cavity and should contain enough rubber to fill the cavity and produce a slight flash. As I told, with compression molding in particular, keeping the molding temperature near the low end of the vulcanization temperature will reduce scorch. Avoid using external silica filler to adjust the hardness or cheapening the compound. This will certainly lead to defect like backrending. Next is controlling backrending in peroxic or mineral filled EPDM rubber. So EPDM rubber can be cured by both peroxide as well as sulfur cure system. In case of peroxic or sulfur EPDM rubber, it is advisable to use non-oil extended EPDM rubber. Next is avoid using antioxidant, especially paraphenyl diamine anti-ozonants, phenolic resins, aromatic and naphthenic oils. Unsaturated fatty acids should be used as minimum as possible. In case of clay-filled rubber, some parts of magnesium oxide or calcium oxide can be added to maintain the pH of the medium. We often add silica in open mixing mill for the purpose of increasing elongation or tear resistance to avoid backrending. But this procedure should be strictly avoided. Silica should be mixed in internal mixer with coupling agent. Concentrations of the sealant coupling agent should be determined based on amount of the silica filler added. Silica sealant mixing temperature must be maintained for effective compounding. It is advisable to heat the silica filler in oven prior mixing to reduce the moisture content, especially in case of peroxide curing of the EPDM rubber. Use of some amount of calcium oxide in silica filled compound is recommended to avoid backrending. And finally, use of preform design nearly similar to the mold cavity is recommended. Lastly, I will talk on controlling backrending on sulfur cured natural rubber. First parameter is improve the reversion resistance of the compound. In case of thick articles, there is a tendency to dissimilar state of cure in natural rubber compound. The high heat history near partition line has a tendency to reversing the state of cure compared to the core. This phenomenon leads to parting line failure and commonly known as burning a parting line. Use of reversion resistance cure additives can reduce the phenomenon drastically. Some of chemicals are N-indus metaphenylene bismaleimide, available as Volcano PM from Auchesinco Chemical Industry Company Limited. Next is use correct weight and blank shape of preformed article. Reduce the cure temperature as low as possible. Apply higher molding pressure. Use delayed action accelerators with optimum doses of PVI to ensure the base process safety of the compound. And finally, ensure proper mastication and order of mixing of chemicals during mixing. Thank you all for joining this session of the tips and tricks. See you next time. Over to Param. Thank you very much.
Okay, thank you very much, Mr. Pranav Bhattacharya, for keeping this valuable your experience into the tips and tricks on the subject on the rubber compound process design to reduce backgrinding. I believe that in the audience and the rubber industry will benefit from this tips and tricks session by you on this topic. So let me introduce you almost end of this session today. Before I close it, the program today, and I'd like to invite you to all of you to participate in the diploma program by Technobase, Executive Diploma 360 degrees, focusing on the rubber industry technology and management. This is basically covering both the technical and the non-technical aspects of the rubber industry, and very good for the people who work in industry. If you're interested in this executive program, please reach out to me. The program starts in June. We open for the registrations now up to end of the April. So that's about the rubber industry technology and management. I welcome you all to our Technobase YouTube channel. If you miss any of the episodes, you can always watch them at our YouTube channel. All of the NewsHour programs are uploaded into the Technobase channel. You can watch them at your convenience. I encourage all of you who are joining the live session, pass on this information to your colleagues and industry friends who might benefit. A lot of technical information is there, definitely useful to all of you. Okay? So we can, how to reach me. This is my contact information. Feel free to reach out to me if there can be any assistance, or you'd like to be part of our programs, or you'd like to contribute, whether it be buyer guide or a business profile or tips and tricks, or business talk, or tech talk. We have various opportunities to be part of this rubber industry news hour. This is your program, every member of the rubber industry fraternity. I see you next week on Monday. Okay, as you know the timeline. See you next week. Thank you all for joining this session today.